juice. But I have lots of work to do, do you see? I can't drink it right now.
It tastes so bad.
Yeah, it's been there for an hour.
But why?
The truth is out there. Let's see what we find in the thermodynamic toolbox.
Henry's law. Using Redlich-Kwong equation in Henry's law, fugacity coefficient was calculated. Carroll et al. Deduced expressions relating solubility to temperature and pressure, which is valid from 0 degrees Celsius up till 160 degrees Celsius.
At low temperature up till around 75 degrees Celsius, solubility curves are similar, but above 75 degrees Celsius, partial pressure of 1 atm, the graph remains constant and behaves asymptotically. From the given graphs, at low temperature, the solubility would increase more as compared to at higher temperature.
That's cool. So you say that I can explain this by using your theory? That carbon dioxide escapes due to pressure release? Pretty simple, huh? So we have Amol Kamath to talk more about diffusion of CO2.
So this is Mr. Amol Kamath, and we will get some views on our topics. And our first question is: in your research career or in your industrial experience, did you experience any phenomenon or process involving diffusion of CO2 in water? And if yes, then how did you approach it?
So in the past, I've worked with a petrochemical firm. One of the byproducts of the whole process is when combustion of ethylene happens with vinyl acetate, which gives rise to carbon dioxide. The problem with carbon dioxide being in a polymer mixture is that it causes the polymer to be porous, which was one of the things that we did not want. So before the precipitation reaction for the polymer, we would have a step where we would go for distillation by using the solvent in the whole process, and then post distillation we would have absorption with potassium carbonate to remove the carbon dioxide from the system. So that was one of the areas where carbon dioxide diffusion in liquids was used.
And Mr. Amol Kamath, can you please share any interesting facts or implications for diffusion of CO2 in?
One of the facts or one of the interesting parts about diffusion of carbon dioxide in water, I would say, is when the oceans, which are abundant in nature, they are like a sponge which absorb carbon dioxide completely from the atmosphere and keep releasing it on a regular basis. The amount of carbon dioxide in the water depends on the soluble content of the water, the pressure, as well as the temperature of the liquid. So right now what happens is, on a daily basis, the oceans take in and give out a large quantity of carbon dioxide, and it continuously varies in the atmosphere. So one of the reasons we have a constant greenhouse layer and greenhouse gas effect is because the oceans continuously emit and change the carbon dioxide content in the atmosphere. That is one of the very interesting part about it.
Okay, so now we want to know your thoughts on one of our research problems for synthesis of lithium carbonate nanoparticles, which is prepared by making carbonic acid first and then which reacts with lithium carbonate to give lithium bicarbonate, but which on precipitation gives back lithium carbonate because lithium bicarbonate is in metastable state. So my question is, will excess carbon dioxide affect the formation of lithium carbonate?
Stoichiometrically speaking, the thing is, with carbon dioxide being in the whole system, after a certain point, after a certain concentration of carbon dioxide in the whole solution, it won't make a difference if you add any more carbon dioxide to the system, as long as the pressure and the temperature parameters remain constant for the solution. Because at a particular pressure and at a particular temperature, the amount of carbon dioxide that will dissolve in the system in a aqueous solution remains a constant. So you would only get as much precipitate as the temperature and pressure conditions allow you to. Any excess carbon dioxide would still just be a gaseous layer without having much influence on the whole system.